Hello everyone. Today I want to tell you how to port your deep learning models on AWS Lambda and make them serverless. So basically, let's start from introduction in case somebody don't know about what basically AWS Lambda concept is about. So basically, we have different types of as a service types, like on-premise, where your hardware is owned by you in your company, and software as a service, where you don't own anything. And function as a service is somewhere between, where almost everything is hidden from you. The only thing you can basically change is code, which is good. So basically, AWS Lambda is Amazon implementation of function as a service. So how does it work? Basically, there is a Lambda configuration which is stored, which is code, libraries, and configuration in terms of memory and maximum time. And there is a container pool, which, to put it simply, just EC2 instances. When trigger starts, it basically can come from API or other ones. They produce event. During the event, AWS uses configuration files and take container from container pool to create this warm container, which processes the event and then produces the response. After that, it is kept warm for 4 to 5 minutes. So in case new event will come through this trigger in these 4 minutes, it will not reconstruct the whole process again. It will use the warm container. So what can act as a trigger? So it can be from things like DynamicDB or S3, meaning each new file in S3 will get processed, or each new database entrance in DynamicDB will be processed. CloudWatch is more like standard cron. Kinesis, which is basically stream of events, which will be processed, each event will be processed by each Lambda. API gateway is basically API. And Lex, which is basically AWS chatbot platform, meaning you can use your AWS Lambda as a backend for a chatbot. So there are a lot of pros, basically, that it's very easy to deploy. You don't have to worry about any Docker or Apache or Kubernetes. You don't have to know about it. You just know to put your code inside. It's very easy to connect inside AWS infrastructure. It's very scalable. So it can 1,000 Lambdas can run simultaneously. If you write to their support, they can increase this number to 10,000. So, and it's relatively cheap. I will show it later today, but it costs a fraction of the cost for the same job on EC2 instance. There are some cons which stop from using AWS Lambda for some production tasks. So basically, logging is not, it exists. It's just not as great as most people would like it to be. It's very hard to debug it locally, so it's very hard to have your local environment which will work the same way as your AWS Lambda. And the thing which I mentioned before about warm containers works pretty unpredictable. So sometimes it can work fastly in a fast way, sometimes it can work in a slow way. And there are certain limitations which limits types of tasks you can work with. So it's no more than 1.5 gigabyte RAM, not more than 500 megabyte disk, and not more than 5 minutes execution time. One additional thing which is not mentioned in direct documentation, but only in FAQ, that when you provision memory, you're also provisioning CPU with Lambda. So if you want your model to work faster, you have to provision as much memory as possible. So next about TensorFlow. So basically, no question here. We understand why we would like to port TensorFlow models on AWS Lambda, because it's the most popular framework right now. So the good news is that right now we have TensorFlow 1.0.0, meaning we have Keras inside TensorFlow model, inside core, which is best news. We have a Google version of boosted trees. So I didn't see the benchmarks, but most people say it will be as good as XGBoost, maybe, I think, better. And there are lots of other stuff. You should probably see the release, because it's a big thing. And so why would we port TensorFlow on Lambda? So basically, because cost is so low, we can get something like 20,000 runs just for $1. We have a lot of concurrent executions. And we have pay-as-you-go model, meaning if you're dealing with events where you don't have, for example, 100 tasks per hour, but you have very peak number of tasks, this Lambda can actually help you to reduce your costs. So what is the current implementation problem with porting TensorFlow on Lambda? That basically the limitation, which I mentioned before, is 50 megabytes. And like the most critical libraries, which is TensorFlow and NumPy, like together exceed this limit. And there are like additional dependencies which you have to add. So basically, it's solvable. So in my GitHub project, you can find the exact shell script. So the only thing you need to do is use Docker to have your local Amazon Linux, and then run this script on this Linux. And then in the end, you will receive a needed library. So because like the only 50 megabytes, we already used 50 megabytes. So when you actually import your model, you have to use S3. So S3 works pretty fast if your Lambda is in the same data center as your S3. So so you can basically update your model, and you don't have to update your Lambda. So you can also change model as you want. Like if you're dealing with TensorFlow, you're actually importing via PB files of protobuffer, and if you're dealing with Keras, you will import a H5 file. So where to get models? The simplest way, like if you want to, you can port your own model, no problem. But if you want, there are like a lot of GitHub projects. There's TensorFlow Zoo, which basically has a lot of pre-trained models, which you can just plug and play, basically. So some projects which were made with my implementation of TensorFlow on AWS Lambda. So the one in my GitHub, which is basically just image captioning, which is porting Inception version 3. So this one costs like 20,000 images for $1. It just produced like captioning for the image. And actually, another interesting project which was done using GitHub AWS Lambda is Accessible Web. So it wasn't done by me, it was done by Abhinav Suri. So basically, it's about using image-to-text model. So for people with disabilities, be able to look at the web the same way we do. Because like it's a Chrome plugin where you can just click on the image, and it will tell you what's happening on the image using deep learning model. So in conclusion, I want to say that Lambda plus TensorFlow equal love. So it's like, I basically think that serverless TensorFlow is the future for deep learning deployments because it's just so easy to do and implement. So since we have time, I will jump to code. So basically, here's my GitHub project. So I port a lot of different libraries. So TensorFlow is just one of them. So basically, what you see here, like 4 files, 3 files, 1 folder. And let me start. Like, if here's shell file, it's very simple. You just run it. So basically, just installs right dependencies, libraries, and does a lot of magic cleaning them, basically. So you don't have files you don't need, and compresses it. So, but also you already have prepared pack.zip. It has a model which I mentioned before, image captioning. So basically, it contains this source folder, which is just libraries, plus index.py file, where like everything is happening. So, and if we look into index.py, so it's just like you just import your libraries as you would in your average project. And you just need to the only thing you need to do is use we're skipping some TensorFlow code. So basically, in handler, what you need, you just download model and some additional files from S3, and then you just import it into TensorFlow in standard way, and then you just put the image. And then it will produce a result, which is kind of like predictions. So let me switch to Lambda UI. So this is like standard Lambda UI, but so where you can just upload it as a zip. So this pack I mentioned before, and it will work from scratch on your Lambda. Because like right now it uses my public S3 bucket, so there is no problem about it. So you can just basically run test. And you can see that it runs in 4 seconds. It's not real time, but it's real time-ish, kind of. So if for some task it could be usable. So as you can see, like for Panda picture, it produces the results of captioning of Lambda image. So and everything works pretty great. Okay, so this presentation is available on this link, and the GitHub project is available on this link. So thank you very much for attention. I would like to answer your questions.
Fantastic talk. Questions? I'll start in the back.
Would you be able to do the same thing with imagenet?
It's possible. So it's like so the guy, for example, who did project for like he used image-to-text model. So the only limit on the model is that limitation which I mentioned before is 500 megabytes. So like you will not get limitation in terms of RAM. So it's hard to exceed like 1.5 gigabytes. But 500 megabytes is kind of a limit, because some models are more than that.
So what is the problem with the performance byte per second? And it does Lambda has access to GPUs?
What do you mean problem with?
You say that it's take 4 seconds to recognize one image. What is the main problem of it? So why it's so long?
The main problem is that I think it's initializing the whole thing. So this is one of the issues with Lambda. So it's with warm container, like if you keep your container warm, it will be faster. But still it will be 3 seconds just because it's not optimized. So my personal perspective is you should optimize your model for deployment. So, and I don't think Inception is like optimized for this.
And do Lambda have access to GPU-based?
That's the problem. You don't have direct access. You cannot provision GPU. Yeah, and obviously, Lambda cannot have GPU by definition. It's CPU. So yeah, but like if you don't train and you just want to deploy your model, I think CPU is okay.
3 seconds. Okay.
More questions? I've got a question.
Oh, okay.
I think it relates to the last one. If the model stays warm, then it will take, this particular one will take 3 seconds rather than 4? Is that what you were saying?
Well, that's the problem. If I like it, best case scenario, if we could like put model inside this archive, it would work extremely fast. But since it always has to download model from S3 and run it, so even with work container, it runs the whole process again. So you cannot have like imported model, and you cannot have like just model. So that's the problem.
And there's no way to check to see if it was already preloaded the last time?
Yeah, I checked, and that's basically when I checked like execution time problems with like on each like line, it was like the problem. Well, one of the ways to solve it, you can Dockerize the thing, and you can run actually Docker inside AWS Lambda. Of course, it completely it completely removes like principles of serverless, but you can do it if you want.
All right, thank you. It's a great hack for a few